This lesson is about functions, sets, domain, and range, and I'm going to start off with a slight apology. It's going to be a little bit blurry on some of the problems because typing math is a really kind of an arduous task when there's a lot of fractions or powers and things, and I did not have time to retype all of the problems here. Some of them were just copy and pasted. So I apologize for that, but I don't think it should be a problem for you to read. So first of all, just some words that we're going to, by the time we finish this, actually these two, let me just kind of go ahead and take that off there. I'm not going to use those in this lesson. Those were when I did 2 lessons at once at one point in time. So domain, range, functions, sets, and interval notation. Okay, these are key words that we're dealing with today, and the biggies are domain and range. But first of all, we look at a function. And it's also got domain and range. I'll tell you what let's do before we say first of all. I'm going to add some things while you watch here. And this will just be some Miss Carr explanation, not necessarily a textbook definition. And we're going to make our text box probably nice and big so it'll all fit. How about that? The domain is the set of x values or inputs used or okay to use. Now, when you are actually looking at a graph, you can say it's the ones they used. But when you are trying to determine what the domain is, you have to figure out what's okay to use, and we have another slide about that. Range. So what is range? By contrast, the range is the set of y values, or we might call that outputs used or resulting. A function is a relation of x and the x and y values such that every x is mapped or paired with to exactly one y. Now, key thing here, every x and exactly one y. We never said that it had to be every y, and we never said that we couldn't use more than one, we couldn't use x again, okay? But every single x has to have one y, and we'll look at what that is. Now, sets use braces. I should put an E on there. And so that's just kind of set notation. And they are often a list of values. Can't type. Or points. Okay, so a set is going to be like that. Interval notation, on the other hand, refers to the values from least to greatest without skipping. So like a set could go 2, 3, 4, 5, but on an interval notation, if you go 2, 3, it includes every little decimal between 2 and 3. That's what I mean by without skipping. And does not include the ends if it uses parentheses, but it does if instead of parentheses, it has brackets. Oh, not a brace, a bracket. Okay? So we will apply that in these next several slides, all of these definitions. Domain, x values, range, y values. But you might want to pause and maybe snap a picture of that so that you can refer back to it as you're doing some other stuff. Because that's kind of the informational slide. So the next one's practice. Is it a function? So you've got to remember, in a function, every x goes to exactly one y. So in this particular case, this x right here, which I know it says g, but what I mean is it's a domain value. It has two answers. It goes to two values over here. When we have arrows like that, this is called a mapping, and you'll find problems just like this in your homework. But since this letter goes to two different ones, the answer is no, it is not a function. Is this one a function? Well, 12 is a domain, it goes to one answer. 11 is a domain, it goes to one answer. 15 is a domain, it goes to one answer. Every x goes to one y. It makes no difference if this one got repeated. Every x goes to one y. So is this one a function? Yes. And this one was copied directly from a homework. That's why it kind of looks like that. You should also be able to determine if a relation is a function from a listing and then identify the domain and range. I've only got the first part screenshotted here, but we'll also identify the domain and range. So in fact, I'm going to identify the domain first. And what I'm going to do is create a mapping, even though I didn't have to. I know that 1 maps to 4. That's this 0.14. 6 maps to 24. And 7 maps to 28. So every one of my domain, we just identified the domain then. There's my domain values. Every one of them maps to exactly one range value. So these are the range values. So it does fit the definition of a function. Every x goes to one y. Yes, that one's a function. A relationship is just any sort of collection of x and y values. It doesn't have to be a function though. So if you have a list like our previous one over wherever I had that, this one was not a function, it could still be a relation. Okay, they're still connected in some way. Now, sometimes you have to be able to get domain from an equation. And I have the slide blank because I'm going to write it down. I have students many times that struggle with this, but you have to watch for two key issues. When you were working with domain from an equation, this is when you're trying to find out which x's are okay to use. So one of the cases that you really have to watch out for, and I'm going to put a 1 here, is you need to look out carefully for fractions. It's not that we can't have a fraction, but if you have a fraction, then you have a numerator over a denominator, and the denominator is really the issue. Okay? That denominator cannot equal 0. For your domain, what you have to do is say the denominator, well, if I could write denominator again, does not equal 0. Then you find out what values make it equal 0 and throw those out because they're not okay to use. You know, division by 0 makes the world explode. So it just cannot happen. So then the other situation you have to watch for is roots. I could have said radicals, but on a roots then what you're really looking for is something like that. And generally it'll be a square root, just kind of like I've drawn here. But any sort of an even root is particularly the issue. Now you probably knew that the top of a fraction was called a numerator and the bottom's called a denominator. You might not know that the part underneath a root is called the radicand. Okay, that's not so very important. The issue though is that radicand. So just like on the other one you were looking at the denominator, here you're looking at the radicand. And what happens on this is the radicand, it's okay if it equals 0, but it can't be negative. So it has to be greater than or equal to 0. Has to be positive. Those are the two cases you're looking at all the time. That is a very important slide. It's a little bit sloppy, but take some notes or take a picture. Okay, you're going to need to know over and over and over. All right, so find the domain. When I look at this, all I need to focus in on those is those two issues. So the issue that I see here is actually that there is a fraction, and I know it's got a denominator. And so therefore, I'm going to say that denominator is not allowed to equal 0. And then even though it says does not equal, I solve it just like an equation. So if I took the cubed root of both sides, that would mean x could not equal 0. So if x cannot equal 0, that really, I can use anything except for 0. So my domain is everything except for 0. So how do I write that down? Well, in interval notation then, I'm not going to be able to fit it in that box, but in interval notation, now let me just remind you of what an interval was. You have to go on values from least to greatest without skipping. And then parentheses means we're not including the ends, and brackets means we are including the ends. So as we go back over here, from least to greatest without skipping, if you visualized a number line and it had 0 on it, 0 is the only number that you have to skip, okay? You're not allowed to use that one. Then what are you allowed to use? Well, you would go from negative infinity all the way up to 0. But remember, a parentheses means you don't use that number. So, and I can't use 0. Then I need to start again on the other side of 0, so I don't want to use it, and I need to go all the way to infinity. Now, the infinities are always open. Always, that's called open when you put a parentheses there. Always put parentheses around infinities. Then you will need to put a U between them. Now, when you're typing this online, when you are typing, you're going to see, you know, that little menu that comes up at the bottom, and this symbol, it's not a U on your keyboard, but you need to click that symbol that is showing up down at the bottom. Okay, that means union, and that means you're using everything on the left of it, everything on the right of it. So the number you're actually not using gets written down twice, and it's kind of like skip it. So when I see this, this is everything from negative to infinity, but I skip 0. All right, the next one, find the domain. Well, here's what I see. That's in the denominator. So I know the denominator is not supposed to be allowed to equal 0. So I have to go x squared minus 6x minus 7 is not supposed to equal 0. Then I figure out what does make it equal 0 and throw those numbers out, which really means I'm going to factor. The factoring in this lesson is not too hard, but there is a little bit of it. We have another lesson where we do more, and then I really review it with you. But what multiplies to 7? Well, only 7 and 1. And then it needs to subtract to be negative 6. So if I put a 7 and 1 in here, but I'm going to have to subtract to get a negative 6, then that must be a negative 7. And you can check that'd be x squared plus x minus 7x is negative 6x, and then negative 7. So then that would mean that one of these two parentheses would have to equal 0 if that were going to happen. So really, x minus 7 is not supposed to equal 0, and x plus 1 is not supposed to equal 0. So again, I'm doing it just like it's equals, but I'm using a not equals, which means x cannot equal 7, and x cannot equal negative 1. Okay, now I'm ready to write my interval. So on this number line from left to right, we're going to start at negative infinity, but we have to skip over these two numbers. So it's going to be a little bit longer. So negative infinity, always open at infinity, always use parentheses. Negative 1 is the first number I would skip. If you could visualize that number line, you know, negative 1 is somewhere to the left of 7. So I'm going to have to skip negative 1. And then I can travel all the way to 7, and then skip 7, and then I can just keep going to infinity. So that's interval notation. What that means, I know it's kind of a crazy thing to look at, but that means you've got to skip the -1 and skip the 7, and everything else would be okay to use. Aha, find the domain. This one is what we're looking at. But notice, oh, I love it, love it, love it. Notice that this one is odd. That little number sitting in front is odd. Now let me take you back to where we had those two issues. When you're dealing with roots, it only matters if that number out there is even. So since this one is odd, there is no problem. Okay? No problem. So if there's no problem, there's no number. That's supposed to be a P. If there's no problem, there is no number I need to skip, which means my answer is -infinity to infinity. Okay, -infinity to infinity. And those infinity symbols are down beneath also. Okay, now when you are looking at a graph, remember I said when you're looking at a graph, it refers to the numbers they did use. So here, if you're finding domain from a graph, you just want to figure out what domain values they use. And it uses all of those points. You can almost visualize it like a car crusher that's crushing this entire graph to the x-axis. If you brought this graph over here to the x-axis, it would use everything in that area. Okay? So it's not a list of values because it includes all the little fractions and decimals also. So it's going to be an interval. And it goes from -8 to 4. But for the first time, we're going to use a bracket. Because what that bracket means is that that endpoint -8 is used. They did not skip it. If you look over there, it's got a closed circle. And the same thing over here, this one means 4 is used. They did not skip it. It's got a closed circle. It doesn't have an open circle. All right, so you're going to use the brackets whenever they actually use that endpoint. All right, this is graph the function with the graphing calculator and then visually estimate the domain and the range. Now they have all of these here, and it's pretty easy for you to look at that, but I'm going to bring this up just so you can see a graphing calculator. I'm going to go to y equals, and I'm going to type that in because this is just like my y. So I have the square root, which is the second function of x squared. So I have the square root of 18 minus, this is my x key up here. It's got x, t, and theta and other symbols on it. And then I hit graph. Now notice my window does not look like theirs. I can just kind of see it's headed down. But if you want your window to look like theirs, that's what these numbers down here are about. And so I can tell it's headed down as it goes to the right, and it does cross the axis. So this one doesn't seem reasonable. This one does seem reasonable. Let's look at the other two. Neither one of these is reasonable. So I know my answer here is going to be C. But I am still going to go back and show you how to adjust that window. So if you want yours to look like theirs so you can double check, what you do is right up here, hit window, and then these 4 numbers right here, minimum, maximum, minimum, and maximum, that's what they're giving you. So I would need to change my minimum to -30 and change my maximum to 30. That's what these numbers are, the x minimum and maximum, and then the y minimum and maximum. So I already had that. So now I'm going to hit graph again, and look, it looks so much like theirs. Isn't that nice? So I know I've got the right one. So that's a window adjustment. Okay, one more domain question, but this one does have this even feature right out here. So this one, reminding you of the 2 things we have to look at. If it's got an even number, you've got to make sure the stuff under the root, the radicand, is greater than or equal to 0. So I need to make sure that 5x plus 4 is greater than or equal to 0. So I'm just going to solve this. 5x is greater than or equal to -4. I subtracted 4 from both sides. Divide both sides by 5. And x must be greater than or equal to -4/5. So now if you can visualize that number line, somewhere on it, there's a -4/5. I know it's between 0 and -1, but that's not real important as far as figuring this out. What we're going to do is say, okay, then my answer needs to start at -4/5 and get bigger. So this is what I'm trying to explain in my interval. So my interval notation, starting at the least okay number I can use, the smallest one is -4/5. And it does include -4/5. So I put that bracket there. And it heads to the right forever, so it's headed to infinity, and infinity always gets parentheses. It's always open at infinity. Okay, and then this is about as ugly as they can get, because if you look at this, I have a denominator, but then I also have a square root. So I'm going to have to take care of both things and figure out what that means before I can do my answer. So first of all, let's deal with the square root. X plus 7 is underneath that square root. So like on the one we just did, it would have to be greater than or equal to 0, which means x would have to be greater than or equal to -7. Additionally, because of the denominator, x plus 5 times x minus 5 cannot equal 0. So that means x plus 5 cannot equal 0, as well as x minus 5 cannot equal 0. So x cannot equal -5, and x cannot equal 5. So now I have 3 different things I've got to consider here. So suppose I have a number line. I'm just visualizing this number line. I wish I could draw a straight one for you. Putting these on here from left to right, there's a -7, a -5, and somewhere there's a 5. Now, I cannot use -5 or 5. Those are values that I'm going to have to skip. Okay, I can't use those. I can use -7 and then head to the right. So I'm going to go to -7 to -5 and then skip over it, do the parts between the -5 and 5, skip over, and then do the other part. So when I write my answer from left to right, I have -7, it does use it. That's why there's a bracket there. Up to -5, skip it. Go to 5, skip it, and then keep going to infinity. Okay, so that's the answer in interval notation. You had to deal with all the things at once. That does finish this lesson. Get in touch with me if you need some help. Bye, guys.